Hi guys, welcome back to Infinite Math Help Squared. This video is going to take a look at the different patterns we can find when we graph transformations of a parent function, specifically y equals e to the x. So here is our parent function. Parent function is y equals e to the x. This is the starting point. This is the graph of an exponential function, or just an exponential equation. And the ones that we're going to look at in this video are going to be transformations of this. So we're going to reflect it, and we're going to look at vertical shifts. The first one we're going to look at is, the only thing that we change is, let's make the coefficient a negative 1. If we do that, we notice that instead of our parent shooting upwards from the left, it's dropping downwards. It's still coming from the left, but it's dropping downwards. So this just flipped over. That's all it did. It flipped over your x-axis. Now let's take a look at what happens if you keep the coefficient the same. It'll stay positive 1, but you change the coefficient on the power. Let's make it negative instead of keeping it positive. If we make it negative, but keep the coefficient positive, we have a reflection over the y-axis. So again, if we come back to our parent, it starts at the left and shoots up to the right. This time, it's actually dropping down from the left and coming down to the right. Okay, so that's how it's different, but it's a reflection over the y-axis. Now, these are not the only types. We're just going to do some basic ones, and let's look at a combination. What if I want to do 2 of them? What if I want to reflect over the x-axis and the y-axis at the same time? This is going to be the result. So instead of coming from the left, it's actually coming from the right, and it's dropping. So it's still dropping down, right? Like what we did over here. We dropped down when we changed our coefficient to be negative 1. It's still dropping down. However, it's not coming from the left. It actually makes it seem like it's coming from the right and coming down. Now, that's not how we read graphs. We read them left to right. But for pattern's sake, right, if we look at the differences, I can expect or anticipate people saying that. Okay, now let's take a look at shifting upward or downward. So this one, if you notice, is a combination, right? It's this one right here. However, we have an addition. We are adding a positive 5 to this. And take a note of how it changes, right? This one is all the way up here. On the y-axis, the y-intercept is 4. But it didn't used to be 4. It used to be negative 1. So, the effect that whole numbers have outside of the function, if you're adding or subtracting them, is that it's going to shift either up or down. In this case, this was a positive 5, so it shifted up. If this was a negative 5, and I encourage you to look for your patterns in Desmos, it's the fastest if you have connection. But that's how that will be affected. Now, let's say you forget all your patterns. The game is not over yet. You can simply use a table of values. So I'll show you one more thing. I'm going to point one more thing out before we go. Table of values for exponentials. What you're looking at here is, let's take a look at our x's. Our x's are ranging from a negative 2 to about a positive 2, and you can get the general idea of the graph. And it happens again over here, negative 2 to positive 2. Negative 2 to positive 2. And you get, in that window, you're getting enough of the curve that you have an accurate graph. Same thing over here with the combination, negative 2 to positive 2. So what does that mean for us? That means, in another video, I can go over this with you. If you forgot your patterns, or maybe you're taking a test and you blank out, all you have to do is a quick table of values, plug it into your equation, and as long as you have these points, you can graph them real quick. Okay, hopefully that was helpful. Till next time.